Hi, Assalamualaikum. So this week we are going to learn a new chapter, Chapter 6, Circular Motion. So let's look at the first subtopic, 6.1, Uniform Circular Motion. Okay, so first learning outcome, describe what is uniform circular motion. So by definition, it is a motion in a circle at a constant speed. So circular motion, kita tahu dia adalah motion in circle sebab nama dia circular. So dia mesti motion in circle and at constant speed. Okay, ni adalah keyword dia, at constant speed. Okay, sebagai contoh, okay, kita boleh tengok dekat pergerakan bulan mengelilingi bumi. So the moon is rotating around the earth at constant speed in a circular motion. Okay, so ada banyak lagi contoh lain untuk circular motion tu kita akan tengok dekat dalam example calculation nanti. Okay, so when we're talking about circular motion, there are two keywords here. First, the magnitude of the velocity remains constant. And second, the direction of the velocity changes as the object moving around. Okay, so here we have a ball connected to a string. So when this ball is connected to a string and then it is spinning, so when it spins, it will form a circular motion. Okay, dia akan form circular motion. Okay, let's say lah kita letak velocity. Okay, not velocity, the speed. Let's say kita letak speed dia sebagai 3 meter per second. Sebab salah satu keyword untuk circular motion adalah constant speed. So kita letak speed dia 3 meter per second. Okay, so when this ball is moving in a circle kan. So dekat point ni, okay, first of all dia dekat point ni kan, and then after some time dia akan reach to this point, and then after some time here, and here to make one complete circle. Okay, so initially this ball is moving with 3 meter per second. Okay, kita tahu kalau dekat point ni, okay, it will tend to move towards this direction. Okay, tetapi disebabkan dia sudah connected to a string, okay, so it will keep moving in a circle. So direction of the velocity here is to the right. Tetapi apabila dia sampai dekat sini, okay, it will tend to move towards this direction. Okay, towards this direction, but still with the same velocity. So kamu tengok dekat sini kan, direction of velocity dia sudah berubah. Tetapi magnitude masih sama. Sebab tu adalah salah satu keyword untuk circular motion. Dia mesti constant speed. Speed dia tidak akan berubah. So di sini pun sama. So at this point, okay, velocity dia pula to the left. And at this point, velocity dia adalah ke bawah. So velocity di sini mestilah tangent to the circle. Okay, apa maksud tangent? Tangent maksudnya dia akan sentuh, okay, sedikit permukaan circle. This is why we said magnitude remains the same, but direction changes as the object moves around. So kalau ada perubahan velocity, okay, sebab kita tahu kan velocity is both magnitude and direction. Dia adalah vector quantity. Walaupun magnitude dia stay the same, tapi direction dia berbeza. So bermaksud velocity ni ada perubahan. So apabila ada perubahan dalam velocity, we can say that, okay, the object is accelerating. Okay, because there is a changes in velocity. So v changes, meaning that the object is accelerating. So here we will always have the acceleration during the circular motion. So this acceleration Miss akan cover nanti dalam 6.2. Okay, so now we look at the terms that we use in circular motion. Okay, first is angular displacement. Okay, ataupun dia punya simbol adalah theta. So dalam linear motion, linear motion kita ada displacement, iaitu kita guna S kan, which is if the object is here and then it moves to point here, point A, ni adalah displacement. But now since we are having a circular motion, okay, bulat kan, so kita panggil dia sebagai angular displacement, which is the angle here. So angle in between here, which is dari point ni adalah first point, and then dia akan bergerak ke point ni kita panggil sebagai angular displacement, di mana displacement is equal to the radius. Radius adalah daripada titik tengah ke point di sini, times with the angular displacement. So this is the formula. And then next one we have angular velocity, which is using the symbol omega. So in circular motion, the object is moving with angular velocity. Maksudnya daripada sini ke sini, ni adalah angular velocity dia. Okay, di mana angular velocity adalah sama dengan delta theta divided by delta t, which we are using the unit radian per second. Or sometimes kita gunakan RPM, revolution per minute. Revolution per minute. But this is the SI unit. Okay, unit yang lain digunakan dalam bagi represent the angular velocity adalah juga revolution per minute. Okay, and then next one is the tangential velocity ataupun linear velocity. Linear velocity. This one, macam yang Miss explain tadi, dia adalah the linear velocity. At this point, dia mesti tangent. Okay, dia mesti tangent. Okay, dia mesti sentuh dekat permukaan circle tu. Kalau di sini pun sama, dia akan tangent macam ni. Okay, dan velocity is always perpendicular to the radius of the circular path. Okay, radius kita tahu daripada tengah ke titik sini, itu adalah radius. So, velocity mestilah 90 degree to the radius. It's always 90 degree. So, we want to relate the velocity with the radius and angular velocity. Kita gunakan formula ni. V is equal to R omega, di mana unit velocity still sama, meter per second. And then next one we have period, which is the time taken to complete one revolution. Okay, time taken to complete one revolution. Let's say lah initially dia dekat sini kan, and then this object is going around and then balik semula ke sini. Okay, dia mesti one revolution. Tu adalah masa yang diambil untuk complete one revolution. So kita panggil dia sebagai period, di mana formula for T is equal to 2 pi divided by omega. So this one is originally from the formula omega, di mana omega adalah sama dengan 2 pi over T, ataupun sama dengan 2 pi F. F adalah frequency. So frequency is the number of revolution per second. Ataupun kita gunakan formula 1 over T kalau melibatkan value untuk period, di mana frequency unit dia adalah hertz ataupun per second. Okay, so these are all the formula that we are going to use in this chapter 6. Okay, the next learning outcome is 6.1b, convert unit between degrees, radian, and revolution or rotation. So revolution or rotation is basically the same thing, which means pusingan. Okay, dalam bahasa Melayu dia adalah pusingan. Benda yang sama lah kedua-duanya ni. Okay, so the first unit conversion here, we want to change from degrees to radian. So you need to take note here. 1 pi radian is equal to 180 degree. So now we want 15 degree in radian. Okay, so kita tahu 180 sama dengan pi radian. Now we want 15 degree in terms of radian. So this one is very easy. So 15 degree multiplied by, okay, dia adalah kita gunakan darab silang lah, because we want this value here, right? So kita darab silang, 15 akan darab dengan pi. and then divided by 180. So 15 times with pi divided by 180. So just tekan calculator, kamu akan dapat 0.26 radian. This one pun sama. Okay, benda yang sama sahaja. So tekan calculator, dapat 2.09 radian. So kita akan letak radian lah dekat belakang jawapan. Okay, just to make sure tu adalah jawapan tu dalam radian lah. Okay, so this one, if you don't remember this value here, kamu boleh gunakan teknik ni lah. Teknik yang senang, mathematics yang very simple. Okay, so next one, kita terbalikkan pula radian to degree. Okay, so this one, kamu hanya terbalikkan this 2 pi over 3 terhadap dengan 180 divided by pi. Okay, dia terbaliklah 180 dekat atas, pi dekat bawah, which is equal to 120 degree. So next one pun sama. You will get 144 degree. Okay, so next one, we need to convert revolution or rotation to radian and degree. Okay, so you need to take note, one revolution, satu pusingan. Okay, satu pusingan lengkap. Oh wait. Satu pusingan lengkap bersamaan dengan 2 pi radian, which is also 360 degree. Okay, satu pusingan 360 degree. Itu kamu tahu kan? So 360 degree adalah sama dengan 2 pi. Okay, so now this one very simple. We want to change revolution to radian. So satu revolution sama dengan 2 pi. So 20 just darab dengan 2 pi. So kamu akan dapat 40 pi radian. And then dalam degree pula, 20 darab dengan 360. So you will get 7200 degree. Okay, so this one, if you don't want to leave your answer as 40 pi, kamu boleh letak jawapan kamu dalam titik perpuluhan pun boleh. Kedua-dua jawapan diterima. Okay, so this one is involving 2 unit, di mana kita ada RPM, which is this one adalah revolution per minute kepada radian per second. So this one is usually the value for the unit for angular velocity. Ini adalah unit angular velocity ataupun omega. So this one is very easy as well. So we have revolution per minute. Okay, revolution per minute. Minute di bawah. And we want to convert to radian per second. Okay, so one revolution, satu pusingan bersamaan dengan 2 pi radian. Dan 1 minit bersamaan dengan 60 second. So bermaksud di sini 6000 times with 2 pi divided by 60. So tekan calculator, you will get 200 pi radian per second. Okay, this one pun benda yang sama, you can try it on your own. So next one, terbalik daripada radian per second to revolution per minute. So 20 times with benda yang sama, kita akan multiply. Tetapi sebab dekat sini kan kita daripada RPM to radian per second, kita darab dengan 2 pi over 60. So now kita mau terbalikkan dia. So 60 di atas, 2 pi di bawah. This one method yang paling senang lah untuk kamu follow. So 60 divided by 2 pi, then kamu tekan calculator akan dapat 190.99 revolution per minute ataupun letak RPM. So this one pun sama, you can try it on your own.